Ing. He's so good at teaching. I love math.
What? Alright, math lovers, let's go to 1.25, solving by using a calculator. We're going to be doing some word problems. And the first thing we're going to do is the same thing. We're going to put this into our calculator, use calculator, and use y equals the button. And note that it has to be set equal to 0. Set equal to 0. Basically, your calculator can only accept standard. It can accept standard form, vertex form, vector form. We're going to learn later on, but it has to be 0. Set equal to 0. Okay. Second thing you're going to do is just press the word graph. Okay. Third, this is where it's a little bit different. We're going to look for the button on there called calculate. We're going to look for a button on there called calculate. And once we press that button, we're going to look for the word 0. Remember, at 0 is where it crosses the x-axis. Okay, that's a 0. So what that is, it's an x value, but the y value is 0. Does that make sense? Okay. Fourth, you're going to do these boundaries. Boundaries. So when it says left boundary, that just means on the left side on the x-axis. Okay? And the right boundary, well, what do you think that means? Yeah, the right side of coming from the right side of the graph. Okay? Let's go ahead and try this problem here. A punter, well, I know it, I missed one. Step 0, it's kind of weird, I always call these step zeros, is draw a picture. Draw a picture, because it conceptualizes what you're doing. Okay, a kicker punts a football. The height of the ball after t seconds is solved by h of t equals -16 t squared plus 50t plus h0, where h0 is the initial height. Okay, let's do a couple things here. You're basically trying to solve for t. And what does t represent? It represents I'm now saddened by my non-straight lines, because I can do that. Okay, the x-axis is really represents t, and t represents time. So really that's what you're trying to solve for, measured in seconds. Now, when you get these word problems, you're confused, you can always do you can change h of t to be f of x, like function notation, or super simple, you can make it like a y. Now, I like to make my t's capital so they're not confused by my x's, or plus signs. And I erased it because I wanted to show you that you can also make this something like this. This is sometimes a little bit more palatable among students. Now, what is that h0 in this problem? It says if the ball is 1.5 feet above the ground when it meets the punter's foot. So initial height, HO, is basically where it starts. So when the punter drops it, it's at 1.5. So basically H0 is equal to 1.5. This here is representing by plus 1.5. Okay, so that's the equation we have to graph. couple other things if you just want to note. Remember, this is y, and that's the same thing as height measured in feet. And you're going to have some guy, you know, kick something, I don't know, 1.5, and then your graph. And we're basically looking for this yellow dot and that green dot. Okay, so let's just put it in our calculator and see what happens. And the great thing about this calculator is, you know, you can just pinch and zoom in. I mean, didn't have that when I was in school 50 years ago. All right, negative 16. Okay, this is why I told you to change from x, because there's no t. Don't use t, just use x. Negative 16x squared plus 50x. Okay, we said plus 1.5. Okay, let's take a look at the graph here. Alrighty, there's my graph. I'm pinching and zooming, and I'm doing all these things. Okay, there's my graph. Okay. All right, what we said was look for the word calculate. So if you put your, on mine, I had to touch the graph, and calc is on the bottom. Okay, so it says left bound, and I'm going to focus on the one that is between 3 and 3.5. And that's actually the perfect numbers to put what's on the left boundary. So 3, my right boundary, is 3.5. I don't know what TOL stands for. Well, once I clicked on TOL, my 0, it tells me is at 3.15. And that's the answer, 3.15. Now, you could have just pressed, there's another one you can do on the regular graphic calculator, just press trace, and then you can move your finger, you know, on the graph, right? Does that make sense? Isn't this kind of cool? Like, okay, there is, okay, so this one doesn't make sense. Negative 0.02 feet in time. You can't go back in time. And take a look at this, you know, the football's going up. And if you look at the white value, that's how high the ball's going, and it peaks out around, and it tells you at 40.56. Okay, but the one we wanted was time, right? And he kicks the ball and it hangs in the air at 3.15. Let's write that. It takes 3.15 seconds for the ball to hit the ground. Okay? And the questions below, you're going to have to do a little bit more work. And what I mean by that is you're going to have to do a little bit more substituting. Okay? So go ahead and pick one, and if you want to see them and do it together, let's do it together. Questions 33 to 34, skip one problem. Physics, use the formula h of t equals negative 16t squared. So I'm just going to copy down that formula. Plus VOT plus HO. Now it's going to tell you HT is the height of the object in feet. VO is the object's initial velocity in feet per second. I don't know. The simpler way to say it, but speed. T is the time in seconds, and HO is the initial height, which we already talked about. The object, round to the nearest 10. Mela throws a baseball. So let's draw a picture. That was something that's super helpful. Can just copy something what we did before, right? Okay, so first thing, throws a baseball with initial upward velocity of 32 feet per second. Don't worry about 32 feet per second, but initial velocity is VO. So that number is 32. The baseball is released from Melo's hand at a height of 4 feet. Okay, released at 4 feet is the initial height, the starting height. So this one is going to represent +4. Use a graphing calculator to figure out how long it will take before it hits the ground. So let's just do calculator friendly or calculator ready equation. I'm going to change that to y because that's what the calculator has. Same thing with t's, I'm going to put as x's. And that's the one I'm going to be putting into the calculator. Negative 16x squared plus 32x plus 4. I'm just going to graph and give myself a visual. Okay, I'm going to focus on over here. So that graph is between 2.0 and 2.2, so I'm going to click on the graph. I could just use my finger and tap it, but this is better because this is more universal. It's calculating what you're coming in from the left side. The left side of your graph is going to be from at 2.0. And the right side is going to be at 2.2. Bum! 2.12. 2.12. It will take 2.12 seconds for the ball to reach the ground. To reach the ground. To hit the ground. So this is 2.12. That number doesn't matter. This is time measured in seconds. You always label. This is height measured in feet. And so the path of the ball that goes like this. Well, starting here at 4. And, you know, and this is going to take 2 seconds. All right, let's try question number 34. I'm going to copy the formula they have. And a punter kicks a football. So let's go ahead and draw a picture. This doesn't look really straight, does it? With an upward velocity of 60 feet. Velocity is this one, VO. So that would be 60. The ball is 2 feet above the ground. Okay, so that is we learned above is the initial or starting point. So that would be +2. They basically want to know what t is. So let's go ahead and fill this in. And remember, we'll just change it to friendly y's. Negative 16x squared plus 60 plus 2. Let's put it in. Negative 16x squared plus 60x plus 2. Let's go to graph. Okay, so it looks like that number is between 3.5 and 4. So I'm going to click on the graph. Then I can actually press the button calculate. We said it was between 3.5. Oops. Go up. There it is. And 4. And there it tells me my answer is x equals 3.78 in the top. Okay, now, you see where the y, it doesn't say actually 0, but that number, if you did scientific notation, would be like 0.0000000028421. So it's like literally 0. But 3.78 would be your answer. So the graph goes like that. What did I say? 3.78. That's what I said. It will take approximately 3.87 seconds for the ball to hit the ground. Okay, so initial height of 2. This value over here is not important because time cannot go. Time measured in seconds. And this one over here on the y-axis, which we ran in space, is our height measured in feet. Okay. And that is lesson, and you just stop and don't do those. This is lesson 1.2. We'll see you guys later. Bye.
Shout out to Mr. Ng for being the best math teacher that there is. And math is easy.